It's true, random access memory and the available of this memory or RAM speeds up your computer, and we all love a nice speedy computer. Now this is up to a point, of course. We can add RAM as long as our motherboard supports that much and our operating system supports that much and our CPU supports that much, and we will see an increase in speediness of the machine because it has more space to store the stuff that it's working on. That's what RAM is all about. Storing the working files, making the graphics work when you're playing a game or editing video. It's storage space for that stuff you're working on right now. Okay, so first of all, let's take a look at RAM in the system. Now notice I have grounded my assistant. Yes, there's a nice ESD strap, electrostatic discharge strap, safety strap that's grounded onto metal on the machine because we don't want to be handling any of this RAM or any of these computer components that are sensitive because we could zap them, fry them. Notice in this system there are 2 memory modules on the right and 2 on the left. So 4 slots for the RAM memory, and they're all 4 filled in this machine. Now notice my assistant goes up and punches this little clasp there, and that allows this memory module to literally pull right out of that memory slot. So there you can see this particular memory module. Notice on the flip side, actually, it's labeled. So we can see this looks like a 4 gigabyte of RAM memory module. And there's additional details there about the exact specifications of this particular memory, and we'll get into those in this nugget. So now she will slide that back in, and you just want to firmly press it in and hear it click into the particular slot. And then once she hears that, she'll make sure it's locked into place by bringing down that plastic lever and literally clasping that against the memory module to hold it in place permanently. So now that we know where the RAM typically is located and how easy it's going to be to take the RAM out of a machine or install new RAM in the machine, the question becomes, how much can we install and what would be the approximate price of buying additional random access memory? Well, the answer is great news. We said there were limitations, but really the limitations wouldn't be on your CPU or your operating system most likely. Just to give you an idea, Windows 10 Home Edition supports, I believe, up to 128 gigabytes of RAM. So that's probably not going to be your limitation. It would be your motherboard. Now, if you don't have your motherboard documentation laying around, I don't, for example, with this Alienware system we're working with today, what you can do is you can go up to one of the manufacturers, one of the vendors that sells RAM, and you can go ahead, and they don't make it, by the way. They're probably just reselling someone else that makes the RAM chips, and you can have them scan your system. So this is one of the many that you could use. It's crucial.com. And right here on their homepage, it says, look, there's 2 ways to find compatible upgrades. Because you see, that's another issue. That's the main issue that we're dealing with, is you have to find memory that will be compatible with your system. You may already have some memory in there, and you may want to add additional memory, but it has to be compatible. And that memory that you're installing into that motherboard has to be compatible with that motherboard. Compatibility in RAM is probably our biggest issue. So notice we can download a system scanner and run that scanner in order to obtain amazing information about the capabilities of our device. So I just executed that scan, and look at this. It identified our machine correctly as an Alienware Aurora R4. That's exactly what I have. And when we went in and visually inspected that machine, what did we find? We found that there was 4 slots, 2 banks of 2. And we saw that there was a 4 gigabyte chip installed in each of the slots, giving us 4, 8, 12, 16 gig of memory. Well, there's incredibly great news here. The maximum memory for this motherboard is 32 gig. So we could go 8, 8, 8, and 8. I could double the memory of this machine. Doubling the memory of this system from 16 gig to 32 gig would most definitely have an incredible impact on performance. Now, this comes at a price. It's $207 in order to get 4 8 gigabit DDR3 PC3 17,000 unbuffered non-ECC 1.65 volts 1024 meg by 64, and we'll discuss what all of these terms mean here in this particular nugget. But the important thing is there are many compatible memory upgrades that we could utilize in this machine. So look at, there's various configurations here at various prices. The most highly recommended and most highly compatible for them is going to be listed at the top of this particular screen of output. Notice something else is cool. They went in and they took a look at things like the storage and how full I am on this particular device. And if we scroll down, they're also going to recommend upgrades in the storage to make our machine perform even better. So we know there's a tremendous variation in RAM out there, and we know the compatibility is key. We got to get the stuff that is compatible with our motherboard, for example. You'll find parity and non-parity RAM was the big deal for many years. This refers to whether there's error checking. This is what parity information is used for, or there is no error checking. The error correcting code was the next technology to come along. You see, with parity, we could detect if there was an error. With non-parity, we wouldn't detect if there was an error, but there would be nothing that could be done as far as correcting an error. With error correcting code memory, there could be some error correction done in certain circumstances. Or again, we're not doing any of this with the RAM technology. You remember when we found the RAM for my Aurora machine, it specifically said that we were getting non-ECC memory when we ordered the compatible memory for my particular system. Another variation that we can have in our RAM is, does it have a buffer or not? Yeah, you know what a buffer would be? That would be a place where information could be stored if there's a bottleneck. If things are starting to back up, the information could be stored in a buffer as it fills up, and then it could be handed on for processing. So we have buffered and we have non-buffered memory options. A lot of times the buffer is called a register. So you'll see a RAM chip. We'll talk about the chips in a moment, but just suffice it to say we have a popular variant now of a chip called a DIMM. And you'll see an RDIMM or a UDIMM. This stands for registered or unregistered and is really telling us whether or not we are using a buffered type approach with the memory. I might as well write out UDIMM so you can see that. Now, another thing that we have, another variation, is are we using a memory module that has RAM just on one side of it? Or do we have a memory module that has double the RAM? And that's what, by the way, we have when we have this D in the word DIMM. We are talking about memory that's on each side of the module. You've got memory on each side. The computer treats those sides separately. And obviously, this is a huge advantage because if we have memory on both sides, we can get more memory into the machine. It's all about expanding the capacity of the RAM you have with the space you have so that your machine ultimately can be more powerful. Now, a potential bottleneck is going to be between your RAM and your CPU. So there's variations in how this works. There can be single channel. And when we say channel, again, we're speaking of the communications between the RAM and the CPU. We need that to be as fast as possible so we can get the best possible performance. So sure enough, there is a double channel technology that's available. There's even a triple channel technology that we have out there to increase the communications capacity, the speed, if you want to call it that, between the RAM communicating with the CPU and the system. So we have all these incredible little details about the RAM that's on a particular form factor. And the form factor that we're so used to dealing with is called a dual inline memory module. And there is one. We yanked one of these out of my PC a moment ago in this nugget. So that's the official name. I was calling it a memory module, but of course the official name is DIMM, for dual inline memory module. It's double-sided, as it sounds like. It has separate connectors on both sides of the chip, and they usually are going to have 168 pins and are 64 bits in width. Now, in portable computers like a notebook or a sub-notebook, we need something smaller because of the smaller size, so we use a small outline DIMM or SODIMM, and we're typically dealing with like 72, 144, or 200 pins, but again, a smaller form factor. In fact, let me bring one in to show you. I think I did a pretty good job of getting this to scale for us, and we can see it's obviously going to be smaller than a DIMM because it's going in a portable computer, and we're not going to have near the room that we would in a larger PC. So we have this small type or the larger DIMM module, but what type of RAM goes on it? I mean, what are the speeds that are capable? Well, there's an SDRAM, and this stands for synchronous dynamic random access memory, and this is synchronized to the speed of the motherboard. Then came along DDR, or double data rate, and this is our SDRAM, but literally doubled in speed when compared to the previous technology. Then the next generation came along, DDR2, and then DDR3, literally indicating greater speeds, transferring things faster than ever before with the memory than was thought possible. So you see these different generations of modular technology built into the RAM, giving us faster and faster speeds. For instance, we had DDR500, which had a 4,000 megabit per second capability when it comes to speed. Then you look at today's typical memory, and we might have DDR3-1600, and it is literally 3 times as fast as the earlier DDR500 type memory. So with all of this knowledge now that we have of all of these variations, let's go back to the crucial site and have some fun looking up the capabilities that we could put into a particular motherboard. So let's have some fun, like I said, and we'll go into the Crucial Advisor tool and we'll just select a manufacturer. I'll say I have a Dell system, and let's see, I've owned so many Dells. Let's see, an Inspiron desktop. Yep, I've owned those before. Let's pull down the models. I literally think I may have had like the 3847. So we'll go ahead and say, find the upgrade for this system. How much memory can we have in this system? There is 2 slots, 2 banks of 1. So we could go ahead and order a 2 8-gig kits. But look at this price, by the way, very affordable. So for this system, we'd get 2 of these 8-gig kits. Now notice what it is. It's DDR3 1600 UDIMM. Remember we talked about the UDIMM? That's the unregistered or unbuffered DIMM module. That's what we're getting, and it's that DDR3 type memory. Specifically the DDR3 1600 that I brought up, which is going to allow us to operate in a 12,800 megabit per second type of speed. And that's alluded to down here. Look at that, the 1218 PC3. That's the particular format of this memory. Notice unbuffered, that's what the U is about in the UDIMM, and it's non-ECC, so non-error correcting code. So we can see these details that are so critical that give us compatibility with the system where we're going to install this memory. Now I want to end this nugget with some real world info for you though on what you can expect with this whole memory upgrade thing that we love so much. Understand that your ability to see the performance increase with your naked eye is going to not increase at a steady rate. All right, what do I mean by this? Let's say we are at a 2 gig system, and then a 4 gig system, and then an 8 gig system, and then a 16 gig system, and a 32 gig system. When you take, let's say it's a Windows machine, from 2 to 4, the performance increase is dramatic with your naked eye. And then that's going to kind of diminish as you go from 4 to 8, and diminish as you go 8 to 16, and diminish even further as you go 16 to 32. So, super steep here, this really noticeable, measurable increase in the performance of your machine because you were probably starving your machine really when it came to RAM down here at 2 gig, and when you doubled it, you really noticed a performance increase, and then that will be far less dramatic as you go up. And of course, it really matters what you're doing with the machine. So I have the 16 gig Alienware system that we saw, and that's used for flight simulation. And after today's nugget, I'm going to go ahead and spend the $200, by the way, and take it to 32. Yeah, for my flight simulator, that is the performance that I'm going to want and need. But at the same time, every day I use a 2 gig Chromebook. That's right, 2 gigs of RAM. And that Chromebook does beautifully. Now, why is that? Well, the only thing I'm doing with the Chromebook is solitaire, email, and web surfing. So the 2 gig Chromebook does just fine for those particular tasks. So when we're thinking about RAM upgrades, I want you to keep all of this that I've given you in mind. Well, this nugget was all about random access memory. We saw there's a couple of different popular form factors these days for getting this stuff into your system, and we know there are many flavors of RAM that we can utilize utilizing various technologies like error correction, no error correction, buffering, no buffering. So lots of different varieties as we saw. We also, of course, very importantly, saw how this RAM would be located in your system and just how relatively easy it is to insert it or remove it from the particular device. I sure hope this nugget was informative for you, and I'd like to thank you for viewing.